So let's look at this particular example. Let's say we have this plate. This plate, the plate thickness is 10 mm, and this one too is 10 mm, and it's connected with two bolts, and each bolt is M20 and is grade 4.6. And then we want to determine the load capacity. Now let's say following the example stated, let me say explained earlier on. Let's say this plate is thickness 10 mm as we have said, and is grade S275. That is, its use strength will be 275 Newton per mm square, and the bolt grade is 4.6 bolt grade, and the diameter of each bolt is 20 mm. So we are going to look at this, let's say single lap joint, and both in standard clearance also of 22 mm. That is, we'll put the clearance in between this one is 22 mm, and we assume that the threads are to be in shear plane. Now we also assume that the edge is sufficient to prevent tearing out. Now the first step is we identify the material property and the bolt data. So what we do is that we, according to BS 5950, we look at the grade 4.6 bolt. When we have bolt diameter of 20 mm, we look at its shear strength, which is 160 Newton per mm square, and then we also look at its bearing strength, which is 460 Newton per mm square, from table 32 of our BS 5950. So let us now look at after getting this, the first thing is we calculate the bolt shear capacity, as we always do. Now for the bolt shear capacity, we already know that to calculate the bolt shear capacity, it is the shear strength and the tensile area. Now so what we are going to do is that we just plot in our value. Is the shear strength as given here is 160 as we have checked, and the area is the bolt area for 20 mm diameter bar is 245. When we do the calculation, we arrive at a value of 39,200, which when we convert to kilonewton, it will give us 39.2 per bolt. Now let us look at this for individual bolt, but since we are using two bolts, that means we have to multiply this by 2 to get the total shear capacity. So when we multiply by 2, we have 78.4 kilonewton. Mind you, this is per bolt that we are checking here. This shearing strength per bolt that we have here, so we shouldn't make that mistake. So we must make sure we multiply by 2. Now after getting the shear capacity, next step is we determine the bearing capacity. That is failure by bearing, the bearing capacity, and we already know that it's both bearing strength times the diameter times the thickness. As we already know, the minimum thickness is what we're going to use, which is 10 mm. The thickness of this plate is 10 mm, as we have here. So we just go straight to the calculation. Shear theta is the area, which is the D times T min times PBB, which we have the diameter is 20 mm, the thickness of the plate is 10, and the bearing capacity is this. So if we do the calculation, we have 92 kilonewton per bolt. So since we are considering two bolts, we multiply by 2 also. We have this for this particular instance. Please, the example is what we have followed previously, so I don't think I should be going forth and be showing us the formula of all this one. As you already know, bearing strength and bolt diameter times the plate thickness. So and we told you that the bolt diameter is 20 mm, so you can see where we got those 20 mm from. So the next step is we calculate the plate bearing capacity, which is KBS times D times T times PBS. So if you do that calculation very well, our standard rule is 1.0, so 1.0 times 20 times 10 times 50 of 460 will give us still the same 92 kilonewton per bolt. If you multiply by 2, we have 184 kilonewton. However, the bearing capacity, as I told you, is the minimum of both the shear capacity or the bearing capacity. That's what we're going to use for our design capacity. So for this instance too, the shear capacity is the lowest among the shear capacity, the bolt bearing capacity, and the plate bearing capacity. So if you look at it, we have 78.4, 184, and 184. So the minimum among them is 78.4. So what we're going to use is 78.4 for our design capacity. So the design capacity of the connection is 78.4, which is governed by the shear capacity of the bolt. So that is all on this particular one. Thank you very much. Have a lovely day.